Hi everyone, just a video now on my MS-CDR 70 or MS-70 CDR rather I've been playing with. Good friend of mine Richard on the Facebook page was mentioning about it. I don't do Facebook, he does. I don't like, I value my privacy, he doesn't care, yeah. So one of the things that people were talking about is this Zoom Effect Manager. Previously I've used it on the B1. Apparently you can also use it on the older pedals like the MS-70 CDR, but people say it only runs on Windows. And one of the things that people were talking about was tempo, and how they'd like to be able to set the tempo of a MS-70 CDR, but they're on a Mac, so they can't do it. Well, basically, normally, if you look at things that 6.8 has written about and G200kg, there should be ways of setting tempo on most of the pedals using standard sysex, and in fact even the pedal will respond to the sysex and tell you that it's looking at it, yeah, but it doesn't actually respond to it. So it tells you it sent it, but it doesn't work. So we have to do it by writing the sysex values. So what do? We turn the editor. I'll be checking this in once I got it right. I'm still not 100% certain at the minute. I think it's good. So we turn the editor on, and then we get the current. We get more data, which basically cleans the buffer, and then we get the current patch, and this will store it in current patch.bin. And then let's have a look at it in MS-70 unpack current patch.bin, and this should go to the pedal, send the command, and return back the data and tell me that the tempo is currently 28 hex rather 40. What the other people tend to do on the internet, they're looking in this space. So this is the raw FX coming back from the pedal. And I think 6.8 called an overflow byte or something, these things here, because this is a space, 20 is a space character, and the name of this patch has got a space in it there, and 8 to the left, 1, 2, 3, 4, 5, 6, 7, 8 is the other set of control bits. So these 7-bit bytes get ones depending on whether the top bit is set or needs to be set in these subsequent bytes. Yeah, and you have to unpack it. And when you unpack it, it uses less space, and in fact, it uses 7A bytes. And we can get that because that comes out of running. If we look at this hex dump minus CP07. So if you send a sysx7 command to an MS to most Zoom pedals, it comes back and tells you one less than the command, so 6 rather than 7. 32 hex is 50. That's the number of patches that you've got on an MS-70 CDR, and 7A is the size. In fact, it's these 2 bytes. So 007A is the size of the processed MIDI. So processed sysx, hence the 7A, okay? So what the other guys are doing, I wouldn't say it's wrong, but they're working in the expanded space, in the 7-bit space. I prefer to work in the 8-bit space, but it does cause some problems because what you do is that, I think this is byte 109, this is byte 110. So you take the top nibble of that. In fact, you take 1F0, one F0 across here, 1F across there from the top to the next bit and that, and you take almost the base of this. You add them together in their natural higher byte space, and then you divide them by 2. So when you go back the other way, you have to do something a bit kinky, and it's a long time since I've written in C, so there's a much easier way of doing it, and I've forgotten it, but I'll find it later. Anyway, so the point is that we can read back the current patch, and we know we've got TapTempo of 40. Now you can either go into the pedal like this and go tappy, tappy, and I get 120. So let's just read it just to make absolutely certain that we're getting 120 back. Boom, boom, boom. And yeah, the 120, look there, 78. And the 78 is because it's F0, and you divide that by 2. Or yeah, you divide that by 2 to get the value you want, yeah. So that's now F05. F0, yeah, F05. So it's actually F0 you get, F0, and you divide that by 2, and that gets you the 78, yeah. So now, what if we wanted to make the tempo 40? Well, we could tappy with our feet until we get it right, or we can say, I'm going to change this to MS-70, I just use a bad name. So we read in the current patch.bin, because that was what we just pulled down, and we say we want 40 for the tempo. It writes the file to new tempo. So now, if we load sysx file new tempo, it should have taken what was in the original and just replaced the tempo bits. That's all, nothing more. And there we go, it goes to 40. Yeah. So let's do it again. Let's say that we're going to take the original patch. We don't need to pull it down. I mean, okay, this current patch now doesn't reflect what's on the pedal, because the pedal says 40 a moment ago. It was a bigger number, yeah, 120, whatever it was. But since we're only changing the 2 bytes anyway and then repackaging it, we can just use a shortcut. So I get it again. Let's make it, I don't know, 156. That wonderful bit pattern you've always wanted to have for a tempo. You send that to the pedal, boof, 156. So, and then the final one we'll do is 250. That's the max you can do. If we do 260, it says piss off, you can't do it, yeah. So let's put it to 250. And then we will send that to the pedal, and it's at the most jackass one it can do. So basically, that's a demonstration that with this software, when I check it in, if you're brave enough, you can use it to set tempo. And what I'll be doing is more settings, because I've been exploring the SysX, and you can change certain things. You can change, I mean, maybe whilst I'm at it, if I click that like that, no, hold it down to get it off. Oh, better put an FX on. So let's put an FX on like bass chorus, yeah? So when we're in the right mode here, this is FX1. So we can say FXMPN1, parameter 1, and we'll set it to 5, say. Now, that sends this command here, but the pedal responds with the complete patch here. If I were to push this right button, I think it is, then it shows me put it to 5. So now if I change this to say 10, it should go up to 10, yeah? And now you see, we see 1, 2, 3. Well, what if we put number 4 to 10? I don't know if we can do that. Well, let's find out. If we click this button here, okay, let's set it to 0. 0 should always be safe. Yeah, okay, off. And now we'll set it to 1. So someone once said that you can't set these values. That's not true, you can. They sometimes respond a bit weird, but you can set them, yeah? 4, 5, 6. So let's turn 6 on. So 6 goes to 1. Yep, there we go. So we can control these things, but there are a whole plethora of things that ordinarily with the zoom, there is a way of sending a sysx to set the FX. There is a way of sending a sysx to set the tempo. There is no volume on this as far as I can tell. I might be wrong. I think there's 2 bytes. I don't know what they do. But I'll put the code on the probably at the weekend. Well, actually, I can't. I'm pretty busy at the weekend. It's my wedding anniversary. But yeah, so basically what I do is go to the main and see what I do. Make it easier, and then you can look at it. Okay, so we check that we've got 2 input files. We read the input file in. We check that the tempo is in the range 40 to 250. We read the file in and we unpack it. So this is taking it from the raw space into the packed 8-bit space. We do some verification in there, not a lot, but a little bit. Then we echo it out to the screen just in case, and we set a we echo out a 1, 2, 3, 4 so we can read stuff easier. Now then, basically we take the new tempo in from the command line, and we pass in the unpacked with the new tempo to pack. That does its magic and puts it in repacked, and then we write the file. So that's basically the algorithm. And if we go up here, we can see that I've begun to look at in the process space, the unpack space, for want of a better word. So I think these are pretty good. I think this gets the parameters correct, yeah. But I still got to be slightly careful because I'm taking a few liberties here, and although it reads them properly, when it comes to writing, I'd have to do a bit of work to make certain I got the right bit mask and all the rest of it. Otherwise, I'll be clobbering data. And the first 4 bytes of a row for an for an FX is the FX ID and the group ID multiplied by 2. Okay, and I know how to get those now. I can get them from the ZDLs, and there are other places you can get them from the ZDLs, and they compare favorably with the values coming out of the analysis here. So it is a doubling. It's a bit shift, okay. Then it looks like we've got the first, second, third parameter and all this stuff. And I just need to do a bit of work. I think Manjot's got a much better way of doing this in Python. And probably he'll be able to get it to work nicer in Python. But I don't know. Maybe I will write it in Python in the end. I did this because I used to use C++ a lot professionally, although you wouldn't think it looking at it now. And the other reason a lot of people are using Arduino and they want to be able to use C rather than Python. Although if you were to use a Pi, you could use Python, and Pis are pretty damn powerful, and they were cheap until this stupid chip shortage. So here you go in the unpack space. Byte 90 and byte 91 are where we need to put the number of. Oh no, sorry. Here we are. 110 and 109 is where we get the tempo value from. So we take the bottom nibble of the 110 and we move it to the left, and we take the top part of 109 and we move it to the right, and then we divide it all by 2, and that seems to give us the tap tempo. And then to go back the other way is slightly torturous. I need to write I mean, when I come to these things up here, I'm going to have to get a much better bit mask algorithm. And I know I used to do this years ago on databases, so it's just a case of doing some calculations and checking it. But anyway, it looks like there is no checksum. I thought there was a checksum. I was being an idiot. I raised the ticket on my own GitHub. I was hoping Manjot would help, and I'm sure he would have done. But in the meantime, I thought about it, and when I was writing the unpacked out, this one here, so this writes out the beginning of the 28 sysx, then we have to expand out all of the bits. And I do it in such a way that you can see the 7 and the 8 expansion, so it makes it clearer for anyone that's a bit confused. And when I came to do this bit, I was being an arse, and I put 1 and not I, and I couldn't see it, yeah. So I couldn't work out why I was getting this crazy value, and I was trying to work out the checksum. And it turns out if you just code properly, this being here, I put the link in there that they discussed it. But actually, if you just code properly and you're not so tired, you haven't drunk so much of your homebrew, then it just works, yeah. So this code will go on the GitHub fairly soon, but we can now control these things quite well, yeah. It's quite neat. And actually, I found that they can run off the USB power. I thought they needed to be powered via a 9-volt cable or battery, but that's not true. Although they make a lot of noise if you plug them in when they're powered that way. Much better to run it off battery. Anyway, thank you for your time. Just to say that we can set the tempo now. It's not as easy as it should be, but it works. It seems to work, and I'll do some more checking before I go live with this, because I don't want to trash anyone's pedal or whatever. So, okay, thank you for your time. Have fun. If there's anything else you want me to look at, please let me know. Richard explained that people on the forum were looking at TapTempo, and they don't have a Mac. Sorry, they have a Mac and not a Windows box. And this code will compile quite nicely on a Mac if you wanted to run it in C, or I can write it in Python. So, thank you for your time, and bye bye.